Doctors sometimes need to work out how much medicine to give a child based on the correct dose for an adult. There are different ways of doing this based on the child's age, weight, height, or some other measure. One rule for working out the child's dose from the adult dose is called Clark's rule. It is C equals W over 68 times A, where C is the child's dose, A is the adult's dose, and W is the child's weight in kilograms. The adult dose of a certain medicine is 125 milligrams per day. Calculate the correct dose for a child weighing 30 kilograms using Clark's rule. Give the answer correct to the nearest 5 milligrams. So the adult dose is denoted by capital A, that's 125 milligrams. The weight of the child is 30 kilograms. So W is 30. W is the weight of the child. So we plug these two numbers for A and W into this formula here. So C equals W, which is 30 divided by 68, and this fraction is multiplied by A, which is 125 milligrams. Now, if we do that calculation, the value we actually get is 55.147. We have to round this number to the nearest 5 milligrams. So we want to see, is it closer to 55 or 60? Well, it's obviously closer to 55. A number that is a multiple of 5 milligrams would be a number like 50 or 55 or 60 or 65 or 70 and so on. So we see which of those numbers this is closest to. It's obviously closest to 55 milligrams. Another rule for working out the child's dose is called Young's rule. Below are 3 different descriptions of Young's rule taken from the internet. In each case, write down a formula that exactly matches the description in words. State clearly the meaning of any letters you use in your formulae. Okay, the first rule is Young's rule. Well, this is one description of Young's rule. A mathematical expression used to determine a drug dosage for children. The correct dosage is calculated by dividing the child's age by an amount equal to the child's age plus 12 and then multiplying by the usual adult dose. So the correct... Okay, let's see now. We divide the child's age. I'll just write down just the word age, meaning the child's age, by an amount equal to the child's age plus 12. And we must multiply this by the usual adult dose. We let the letter A stand for adult dose, as you saw in part A. Again, we divide the child's age, which I'm just calling age, by an amount. So we divide, put it over an amount equal to the child's age plus 12. So we just write that as age plus 12. And then we multiply by the usual adult dose. Now presumably we multiply all of this fraction by capital A, where this capital A stands for adult dose. You know, there's quite a difference between multiplying the entire fraction by A or multiplying the denominator by A. Most likely we multiply the entire fraction by A when it says then multiply by the usual adult dose. Here is a second description of Young's rule. We add 12 to the child's age. So I'll write this over here for part 2. We add 12 to the child's age. Well, we can write that as age plus 12. And we add 12 and we divide the sum by the child's age. So we take this sum and divide it by age, and then we divide the adult dose by the figure obtained. So remember, capital A stands for the adult dose, so we divide the adult dose by this figure. This is the figure obtained, so we take the adult dose and divide by this. But actually we can write this as age over age plus 12 multiplied by A. See, if we take A and divide it by this fraction here, dividing by a fraction is equivalent to inverting this fraction. So we turn this fraction upside down to get age over age plus 12 and then multiply by A. It's like dividing, say, 2 by 3/4. That's equivalent to 4 over 3 times 2. Same story here. We invert this fraction and multiply by what's on top. So we invert this fraction down here and multiply by what's on top, which is capital A for the adult dose. Here's the third description of Young's rule. The dose of a drug for a child is obtained by multiplying the adult dose by the child's age in years. Let's do that bit first. The adult dose is capital A. We multiply by the child's age in years. So we multiply by age. And we divide the result. So we divide this by the sum of the child's age plus 12. So we sum the child's age with 12. Okay. Part C. Explain why the three formulae in Part B above all give the same result. Well, it's pretty clear. I've already explained Part 2. We show that we can write this expression like this here, which is the same as for the description of Young's rule from Part 1. So this here is the same as this. And the third description of Young's rule is identical to this here. If we just factorize A out of it, we can write it like age over age plus 12 multiplied by A. Okay, I just use a dot for a multiplication sign there. Doesn't matter. We can just take that A out of the top, or numerator of this fraction. So you can see that the three descriptions give exactly the same formula. So there's no real way I can explain this in words, of course. It's just a matter of showing that the three formulae are identical. The three of them are equal to this here, which is what we got for the first description. The adult dose of a certain medicine is 150 milligrams per day. According to Young's rule, what is the correct dose for a 6-year-old child? Well, age stands for the age of the child. So age is 6 in this case. So we put 6 in for age. And A is the adult dose of this medicine, which is 150 milligrams. So we have 6 divided by 6 plus 12, which is 18. And this number is multiplied by 150, so it's a third of 150, which is 50. Young's rule results in a certain child being given 1/5 of the adult dose of a medicine. How old is this child? So the child is given 1/5 of the adult dose. So A is the adult dose. The child's dose is C. So the child's dose C is 1/5 of the adult's dose, which is A. A stands for the adult's dose. So C is equal to 1/5 of A, or A divided by 5, or 0.2 times A. So we plug this into the formula for Young's rule. So we have age over age plus 12 multiplied by A equals C. But for C, I will plug in 1/5 of the adult dose. The child's dose is 1/5 of the adult dose. Now, we see that we can divide both sides of this equation by A. You can imagine putting all of the left-hand side over A and put the right-hand side over A. See, these two things are multiplied here, so we can cancel these A's. We can divide A by A. So we're just left with age over age plus 12 by 1, or just age over age plus 12. And on the right-hand side, these A's cancel. So we end up with age over age plus 12 equals 1/5. And there's only one unknown in this equation. The unknown is called age. I could call it x, to make it easier to write this down. Write down an equation. But I think I will leave it like this. So 5 multiplied by the age equals 1 times the age plus 12. We can cross multiply because we have a single fraction on each side. So here I have it written out in a straight line. 5 times age equals 1 times age plus 12. Well, 1 times age plus 12 is just age plus 12. So we have 5 age equals 1 age plus 12. That means 4 times the age equals 12. Where age is the child's age. So the child's age is 12 divided by 4, which is 3 years. Another rule for working out a child's dose is based on body surface area, abbreviated BSA. The rule is child's dose equals child's BSA in meters squared divided by 1.73, and all this fraction is multiplied by the adult dose. BSA is difficult to measure directly, but an estimate can be calculated from a person's height and weight. The chart below allows you to read off the BSA for a given height and weight by drawing a straight line from the height on the left scale to the weight on the right. For example, the dotted line shows a person of height 100 centimeters and weight 16 kilograms has a BSA of 0.67 meters squared. So let's look at the example. The person's weight is 100 centimeters, and the person's height is 100 centimeters. The person's weight is 16 kilograms. So this dash here is 15. So this one above it is 16, of course. So we draw a straight line from the person's height in centimeters to their weight in kilograms, and where that straight line crosses this scale here, we have the person's an estimate for the person's body surface area. This estimate is in meters squared. The correct adult dose of a certain medicine is 200 milligrams per day. Use the BSA rule to calculate the correct dose for a child of height 125 centimeters and weight 26 kilograms. Well, 125 centimeters is here, and the weight is 26 kilograms. So this is the 25 kilogram mark. This point here is the 26 kilogram mark. So we have to draw a straight line from this point to this point to see what the child's BSA is. It looks like this value is midway between 0.9 and 1. A number midway between 0.9 and 1 is 0.95. So, to get the child's dose, we want an estimate for the child's BSA, which we see is 0.95, divide by 1.73 and multiply by the adult dose for this medicine, which is 200 milligrams. So we have 0.95 divided by 1.73, and this number is multiplied by 200. Okay, so I'll write this down to, say, one decimal place, 109.8 milligrams. The following apply in the case of a certain medicine and a certain child. The child is 9 years old. So the age of the child is 9. Clark's rule and Young's rule both give a dose of 90 milligrams per day. Here I've written down Clark's rule, which you saw earlier, and I've also written down Young's rule. So these rules give the C is the child's dose, and for both of these rules, if we use both of these rules for this particular child, we find that C is 90 milligrams. Same here, C will be 90 milligrams when we use Clark's rule and Young's rule. Then the BSA rule gives a dose of 130 milligrams. The BSA rule is written down up here. Child's dose is abbreviated to capital C, as it was for Young's rule and Clark's rule. For the numerator, I've just written BSA. The adult dose, as we saw before, was denoted by capital A. So I'm using the same notation here for the BSA rule as we used for the previous two rules. We want to find the weight and height of this child. So we need to plug in some numbers here and try to solve for the weight. Well, the weight appears in Clark's rule. You might be wondering, how do we find the height? Well, we find the height from the BSA. If we can work out the BSA and if we know the weight, then we can go to this chart here to find the height. We just connect the value we get for the weight to the BSA, draw a straight line to find the height. For Young's rule, the child's dose C is 90, and we know that the age of the child is 9. So we can plug 9 in for age here. So I will write Young's rule down over here, replacing age with 9. So we have 9 over 9 plus 12. And it's multiplied by A, the adult dose, which we don't know. And this must give us C, which is 90, using Young's rule. We can solve this equation to find out what A is. A is the missing thing here. So A is 90 multiplied by 9 plus 12 over 9. Well, 9 plus 12. Well, first of all, this fraction here is 9 over 21. So we've 9 over 21A equals 90. 9 over 21 times A. We can leave off that multiplication sign, of course. So that means that A is 90 divided by 9 over 21, which is equivalent to multiplying 90 by 21 over 9. So we divide 90 by this. It's the same as inverting and multiplying. So we calculate this thing here. 9 to the 9 goes once, 9 to the 90 goes 10 times. So we get A equals 10 times 21, which is 210. Now with this value of A, the adult dose, we can then go and look at Clark's rule and calculate W, because we know C. Using Clark's rule, C happens to be 90. And we have A, which is 210. So the only thing missing is W. So here is Clark's rule. I've replaced C with 90, and I've replaced A with the value we just got, which is 210. So we just need to solve for W. You could maybe show this in more familiar terms. We could write this as 210 over 68 times W equals 90. We could write it like this, 210 over 68, and it's multiplied by W. So W is 90 divided by 210 over 68. Well, that's just the same as taking 90 and multiplying by 68 over 210. Or multiplying both sides by 68 over 210. If we multiply 210 over 68 by its reciprocal, which is 68 over 210, we just get 1W. And we do the same on the other side. So anyway, 90 multiplied by 68 is 6,120, and we divide that by 210. So for W, we get a weight of 29.14 kilograms. Now, knowing W, we can at last get to the BSA rule. We can plug in the values that were given here for the BSA rule. We're given that the BSA rule gives a child's dose C of 130. A, the adult dose we found was 210. So we plug those numbers in. So we have C, which is 130, equals the BSA divided by 1.73, and this is multiplied by 210. So we can calculate the BSA. Well, we just multiply 130 by 1.73 and divide by 210. So I'm sure you're okay with that. I won't write that out. We take 130, multiply by 1.73. That gets rid of the 1.73 denominator. Multiply both sides by that denominator. And then we divide across by 210. So the BSA is 1.07. So let's see where that value is on the chart. So here's the value of 1 on the BSA chart. We want the value 1.07. So you can see the next significant figure here is 1.1. So we're going from 1 to 1.1. So we need to look to see where 1.07 is. So it's actually 7 of these. There's 10 of these tiny dashes between 1 and 1.1. So we want to go to 1.01. This one here is 1.05. So we have 1.06 and then 1.07. It's actually quite hard to see it here on this scale. So there's 10 small dashes between 1 and 1.1. So we go to the 7th one. So this value here is 1.07. Then we'd have 1.08, 1.09, and then finally 1.10 or 1.1. So that's the BSA. The weight of the child is 29.14 kilograms. So that's slightly more than 29. There's 29 kilograms. So we draw a line between these 2 points and we extend it out to this chart here, and that will give us an estimate of the weight of the child. So here is my attempt. Let's look at this value here. It looks like it's 146 centimeters. So these are the 2 answers to the question.